Hi, today we're going to go over lesson 12.2 over tangents. So a tangent itself is a line, and that line will touch the circle at one point. So the definition from the book is a little confusing, and we'll go ahead and read it. It says a tangent line to a circle is a line in a plane, so we know it's a flat surface, of a circle that intersects the circle in one point. So again, don't overcomplicate it. It's one line that touches at one point. So let's jump into Theorem 59. If a line is tangent to a circle, it is perpendicular to the radius drawn to the point of contact. Okay, so a couple things. First, Harold uses this word point of contact. Most books won't use that terminology. It will use this point of tangency. So we can use both interchangeably. If you see a point of contact, you know that means point of tangency. Again, the point of tangency is literally just where they intersect right there. It's the point where they intersect. So these two theorems, 59 and 60, are converses of each other. So if we know it's tangent in the first one, then we know it's perpendicular. For theorem 60, if we know it's perpendicular, then we know it is tangent. So we're pretty familiar with converses, so I want to keep going to make the video a little bit shorter. Next up, we have some sample problems here. And let's make it a little bigger. Oh, I kind of messed it up. Oh, okay. Don't you like when it messes up in the middle of a video? Okay. Here we go. Next. Now, the first one, we haven't really learned this yet, so we're just going to cross this one off. We don't need to know that one just yet. We'll learn it later. For the next one, this is just a Pythagorean problem because it says to find the measure of x. C is the center of the circle, and all lines appear to be tangent or tangent. So we know if this line is tangent, then this is a 90-degree angle, which means we can just do Pythagorean. And so your hypotenuse is x. And we're going to use 12 and 7 as the legs. Okay, so I am home and I don't have a calculator, so I'm just going to use my phone calculator. Let's figure this out real quick. So we have 144, 12 squared, plus 7 squared, which is 193. And then we're going to square root that. And I don't have a bunch of room here. So x is 13.9 when I round it to the tenths. Okay. Next one. Again, lines that are tangent appear to be tangent. So we know there's a tangent here, which is a 90, and that's a 90. And so if you have a four-sided figure and three of them are 90 degrees, we can also figure out that that is also 90 degrees. So that's a square. And we're kind of backing up to that A. Let's go ahead and talk about A. There is a rule that says if you have two tangent lines that meet, they're just the same measure. So it's super easy. We know those two are the same. And again, we can figure that out without knowing A, just because if this is a radius and this is a radius, then we can figure out that they're all going to be the same. They're all going to be a square. So x is 14. Okay, for D, let's see, a radius is 6, so x is just the diameter. So the diameter is 12. Now this one, we're going to have to draw in the radius. And we know that radius is 12 because we see the radius here. This length here, if you look only at the left triangle, that is 12 plus x, or x plus 12. Now, we did it this way the other day in class, and it was long and horrible. And so here's an alternate way of doing this that's much easier. Let's just do Pythagorean. Let's just call this a different variable. Let's call this y. And if I can find y, I can just subtract 12 from it, and then I know x, which in a sense is a much easier problem, and we still solve. So, let's make it easier on ourselves. So let's see, we're going to say y is the hypotenuse, and 12 is a leg, and 16 is a leg. So let's get your phone or your calculator back out. We have 12 squared plus 16 squared is 400. And the square root of 400 is 20. So what we're going to do now is we're going to take 20 minus 12. So we know x is 8. And honestly, this very next problem is pretty much the same thing. We know these are both radii, so that's 12. And so that turns into 20. So we can do Pythagorean again. I mean, they're technically telling us different things, but it's the same numbers if you look at it. Okay, let's just go ahead and do the math. So we have 400, 144, and 400 minus 144, and then square root it. X is 16, and we probably could have predicted that. I don't know what this is popping up. Go away. Okay, let's go on. In the diagram, BC is the radius to circle C. Determine whether or not they are tangent. Okay. So if it is perpendicular, then we know it is tangent. We are using the theorem from up above. Let's see what number it is. If it is perpendicular, so we're using this one here, which is 60. Okay, on the first one, they do tell you it's a right angle. So right away, we know this is theorem 60. Here, they don't tell you if it's a right angle. So we're going to have to do like a Pythagorean triple and see if the left side equals the right side, or do the converse of the Pythagorean theorem. And this is the most popular right triangle. And so maybe you already know that 5 squared equals 3 squared plus 4 squared. So this is 25 equals 25. So then again, so we're really using two things. Again, we're using the converse of the Pythagorean and then theorem 60. So yes, this works, theorem 60. We do know that's a right angle. Okay, next one. Is 7 squared, that's a question mark, is that really equal to 3 squared plus 6 squared? So is 49 equal to 9 plus 36? And hopefully you're saying no. So this one is not tangent. All right, so the next part will take a little bit of algebra, and I hope I have room here. It is different than the one above where we did that little shortcut. My hypotenuse is here, and it's r plus 2. So what we're going to do is we're going to do Pythagorean. And when we do that, we get r plus 2 squared equals 4 squared plus r squared. Now, guys, you're going to have to multiply this out, r plus 2 squared. Now, you did this in Algebra 1. Some of you used Punnett squares, like r squared, 2r, 2r, and 4, and you add these together to get r squared plus 4r plus 4. Maybe you learned a different way. Again, we're just multiplying this out. You cannot just distribute like this. That is wrong. You will not get a middle term. We need a middle term. So I'm just going to use the Punnett square for time's sake here. And that equals 16 plus r squared. Now something really nice happens. If you have r squared on the left and right side, they do just cancel out. So if you subtract r squared, they're gone in a sense. So if we subtract 4, 4r equals 12. Divide by 4, so r is 3. So really the hardest thing about this is remembering how to FOIL the hypotenuse. So we have a couple to practice. So this is r plus 8. So r plus 8. Now again, this is Pythagorean, so you square it. Make sure you use parentheses. R squared plus 12 squared. Okay, Punnett square time. R plus 8, R plus 8. So R squared, 8R, 8R, 64. Add those up and you get 16R for your middle term. So R squared plus 16R plus 64 equals R squared plus 144. Hey guys, again, the R squareds cancel out, which is really nice. Subtract the 64. Okay, so that's, I believe, 80. Let me get my calculator back out. And 80 divided by 16 is 5. All right, one more. Let's try it. R plus 9 squared equals R squared plus 15 squared. Okay, again, do the Punnett square, or however you're most comfortable multiplying this out. So I get R squared, 9R, 9R, and 81. So when you add your middle term, you get 18R. R squared plus 18R plus 81 equals R squared, and I'm running out of space, plus 225. The R squareds are gone. I'm just going to rewrite it because there. All right, let's get a calculator out. We'll subtract the 81. We have 225 minus 81 is 144. And divide by 18, which is 8. Come on, pen. R is 8. It won't write. There it goes. Whew. So, last but not least, and this will be interesting without a theorem sheet. Okay, now we haven't done a proof in a while, so let's jump back into it. We have a rectangle, TWNE, and this is circle I. Rectangle, okay, so the first step is given. How do we know that angle ENW, how do we know that is a right angle? Okay, now remember, that is the point of tangency, but we can't just jump into it. We can only use previously given information. So from step 1, how do you know that's a right angle? We know that because the definition of a rectangle is all the angles are 90 degrees. So this is definition of rectangle. Now, if it is a right angle, how do we know it's perpendicular? So this is Theorem 7, and I know Theorem 7 says perpendicular lines form right angles, but as we've learned throughout the year, he often does it backwards, even though it's not written that way. So it's technically the converse of Theorem 7. So last but not least, we are going to use one of the theorems from today, and I'll have to go up and see which one it is, 59 or 60. If it is perpendicular, how do we know it's tangent? So let's go up and see which one we should use. All right, so if the line is perpendicular to the radius at its outer endpoint, it is tangent. So that is definitely theorem 60. If my pen will write, theorem 60.